Good morning, everyone. Welcome to the Autodesk booth. Come on in if you're happy to be walking down the hallway. So today we're going to be looking at a presentation of Maya 2016. This is a really big release for us. We're super excited about it and getting to share it with you guys. We're going to be using some assets based on Hyperspace Madness. And Hyperspace Madness is an internal production that's being done by a bunch of people at Autodesk. So some of the marketing people like myself have been working on it a bit. A lot of the developers are working on it. And it's giving us some real data sets to work with to really find production limitations inside of Maya and address those. And a lot of the results that have come out of working with this data is actually showing up in the software. So you can see that we're using Shotgun to manage this project. It's a great tool for managing all kinds of collaborative workflows. And when we're working on Hyperspace Madness, it's around the globe. I'm working on the East Coast. There's people literally in every geographic almost in the world. So it's pretty awesome that Shotgun gives us the ability to communicate efficiently. So you can see as we scrub through this guy, I mean, these are literally changes that are happening daily. This is an ongoing project. And this is a rough comp of some of the assets that we're going to be working with today and showing a lot of the new features that are in Maya 2016. So this was actually rendered on the Amazon cloud, so thanks a lot to the Amazon cloud services guys. They gave us the ability to actually get this, to even show you anything, because we were working to the very last minute on this, and this is still early work in progress. There's still more work to be done. But what we're seeing here is some of the new improvements that were made to Bifrost, the ability to have a foam model on top of the water, the Bifrost Aero Solver giving us all that nice atmospheric effects, and obviously this was all rendered out inside of Mental Ray. So there's some XGen stuff in there using some of the new XGen shaders that Mental Ray has in Maya 2016. So let's go ahead and just stop this from playing back, and we'll jump into the application. And I'm going to be walking you through basically the 8 high points of the application. So we're going to be touching on a variety of different workflows. First thing that we're going to start off with is going over the new look and feel inside of Maya. Let's actually get over to this cut. This is the one we want to demo that with. The new look and feel inside of Maya 2016. So if you've used Maya in the past, if you pull it up now in 2016 and you begin looking at it, you're going to say, well, yeah, it looks a little different. And this is actually really pretty amazing. What we've done is we've taken the user interface and we've made it be able to scale. So if you're working on an Ultra HD display or a Retina display or a laptop that's got a very high resolution display, the icons inside of Maya will scale properly. All the windows inside of Maya will scale properly. And we've also taken the time to change the icons slightly. So obviously they have a new flat look. And not only are they kind of current looking with their new design, they're also color coded. So this allows you to quickly visually understand what a certain icon, what kind of function it's going to perform. So all the NURBS tools or the modeling tools that are based with NURBS, so like curves tools, are going to be one color. Polygon modeling tools are another color. The sculpting tools are kind of, they work on polygons, so they're the same color. And then things like the FX tools or the FX caching are yet another color. So it's, again, we're just trying to make it easier for you to understand, well, if it's this color, that means it's going to be working with this type of, it's going to be giving us this type of feature. So another thing that we've done with the user interface is we've taken the time to kind of clean up our house. Maya's been around for a long time. It's got a great legacy, but a lot of the tools over the years have just been put in random places. So when we were doing this user interface refresh, we took the time to also reorganize things and group them based on tasks. So things are going to be in slightly different areas. The same UI, workflows, same ideas of the way the UI works, but tools will potentially be in different areas than they were previously, and that's just to make things more contextual. And that's going to really actually make it much easier for not only old users to work efficiently, but new users coming into the application, having a little bit of logic behind where things are placed as opposed to just being everywhere is going to help out tremendously. So an example of that is if we look at our menu filtering here, we can filter between modeling tools, rigging tools, animation tools, and FX tools. So if we jump into rigging, all the things that you would expect to do with rigging are going to be underneath that kind of filtered version of the menu tool set. So this top menu bar changes to give me things like skeleton, skinning, deforming, constraints, control. So again, all the stuff that you would do to rig a character or rig anything in your scene, a car, a tree, whatever, all those tools are going to be under the rigging section. So another thing that we've done with the look and feel is we've updated and completely overhauled the hypershade window. So the hypershade window has been around inside of Maya forever. It's where you generate all of your looks and materials that you will apply to objects both in the viewport as well as in the software renderer. And we've really put a lot of effort into this, and we've developed a pretty cool, we've added a lot of functionality to it, basically. So let's just walk you through that really quickly. So the first thing right off the bat you're going to notice is, well, there's some other windows in here. There's this thing called Material View. And this is a floating window inside of Maya. Any of the floating windows in Maya can obviously be docked. It's all based on Qt. The thing that's interesting with the Hypershade window is inside of this, we can now nest other floating windows. So you can completely reconfigure the way this Hypershade is set up. And I'll walk you through that really quickly. So let's just go ahead and close that material view down. I'm going to grab something like the property editor, and I'm just going to drag and drop that over here. So you can see I can dock that anywhere I want. Then I can grab something, I don't know, we'll get the material view back one more time, and we'll just put that up there on the top. So it's very customizable. You know, if I don't want my create window over here, I could move that around. Or if I wanted to have on top of that create window, maybe something like my outliner. I use my outliner all the time. If I drop it on top of it, it's going to put that outliner in a little tab layout. And we also have our bins over there. So really what I'm trying to drive home here is you can make this behave exactly how you want. And we've added all the things that used to be all these different little windows kind of scattered around Maya into an easily configurable, efficient area to work when you're generating textures and looks and feels. Not only have we made it more configurable with the ability to do all this docking, we've also added a lot of new functionality to it. Things like the material view. So what does that mean? Well, obviously I've got my node editor down here in the bottom. That's going to be using the nodes and the graphing to build our shaders. It now has tabs. These tabs are actually saved with your scene. So if you've grafted something and it's this big elaborate graph and you've got it laid out just the way you want, you close your file down inside of Maya, you can open it back up. That graph will be preserved. It'll be maintained. Very important. And we've also got the ability to have a filtered view in the property editor. So the property editor looks a bit like the attribute editor that was inside of Maya previously. And it is. It's very similar. It's actually just a filtered version of the attribute editor. So you can see that our view is set to look deb. What that means is we're stripping out a lot of the stuff that probably an artist doesn't need to be exposed to when they're trying to just generate shaders. If you wanted to get back to the full list of attributes that a given node might have, you can go ahead and click on this little icon. And obviously, there's things in here that it just people aren't going to need to play around with on a day-to-day basis, like the vector rendering controls. So that's why we've kind of given it the ability to have this filtered view. Just, again, trying to make things easier for new users. That's one of the themes that you'll notice with Maya 2016 is it's all about speed, and we've really tried to make it kind of fresh and current and new and much easier to use. And everyone, again, will benefit from this, new users and old. So the next thing that we want to talk about, it's kind of cool, is this property view window. If I start holding down my shift key and selecting objects, again, they'll load into tabs, so you can really quickly get back to the things that you were working with. These little speed improvements and little workflow things are going to have a big impact on your day if you're doing any type of look dev work. So the last thing that I want to draw your attention to is the material view. And the material view is pretty cool. And we're going to be doing a couple things with this material view in just a second. So what we're going to do is we're going to go ahead and just kind of make this window a little bit smaller so we can see our scene slightly better over here, something like that. So right now I've got my sand shader kind of selected, and we're looking at this on this material view. It's a sphere. You can see that our render type is set to hardware. So at any time, whatever shader you select, let's go down here and grab something like a mental ray shader or something like this car paint shader. And it's going to show it in hardware. So the car paint shader is kind of this ray traced metal flake, really cool shader. Hardware renderers can't really handle that. So what we're going to do is we're going to switch this material view over to mental ray. So now what happens is we're actually getting a little ray traced preview inside of that material view. And we can actually take the type of geometry that this is being previewed on and change it. So in this example, I'm just going to go to the shader ball, which is going to give me little fillets, little roundeds, little edges. So if you're trying to view something like car paint, having a slightly more complex piece of geometry underneath there as your base to work on top of is going to be much better. We can also, and this is really pretty sweet, go in here and start to add in some image-based lighting. So right now we sort of have an area light on there. You see that little reflection of that bright area light? That's what we're lighting it with. If we go in here and we turn on something like exterior color 1, it puts it on almost like a parking lot or a tile floor there. But you can see that it's kind of recursively getting better. It's iterating on the rendering there. It's getting more refined, looking better as it goes along. And we're getting all that indirect illumination inside of that. So we're getting all that secondary bounce. So it looks relatively photoreal. And this is very fast to prototype your shaders in. Pretty awesome. It's worth mentioning that this is fully integrated with the color management inside of Maya, which was introduced, I think, a couple releases ago now. We've been making slight improvements to that as we go along. And the last thing that I want to draw your attention to is the fact that you can add your own image-based lighting probe. So if you've got a scene or some environment that you want to add in here, very simple to add that stuff inside of there. So the next thing that we're going to do is we're going to go ahead and we're going to jump back to this sand, and we're going to talk about the soloing workflow. So when you're building up shaders, a lot of times you're going to be combining things together, and you're going to get very complex shaders. And sometimes you need to filter down and isolate and view just one thing by itself. And we now have a functionality called soloing that allows us to do that very efficiently inside of Maya. So let's check that out in action. So we're going to switch over back to hardware view. I don't want to see that guy. We're going to be doing the soloing workflow just on this sand. We'll use the sand since it's already up. Let's kind of move this over here and zoom in here. So if we do something like solo a texture,
if I hit the S on there and solo the texture, notice what happens in my viewport. The shadows disappear and all the lighting contribution disappears. So we're seeing this as a complete flatly shaded surface. It gets rid of all the lighting contribution so that you can see exactly what that texture is and what it's assigned to in the viewport. It also switched my material view to a flat view. So again, it's a texture map. It knows it's a flat object. It's going to show the material view in flat, isolate it in your viewport. So this allows me to go in here and start to make changes or modifications to this and see those effects, in context, isolated out from all the other lighting and contributions and things in that shading network. Pretty cool. So the other thing that you can do with the soloing is it's really smart. Like if you solo a bump map, well, if you solo a bump map, what it's going to do is it's going to actually, and we'll just ray trace this one too. We'll put that back to ray tracing. And what it does is it puts it into, it removes the color map, it makes it white, and it lets you visualize the bump without anything except the shading in your scene, the lighting in your scene, and it removes the color, essentially, and all the specular. So if we kind of look at this, in an area like that, let's see here, if we kind of zoom over to an area where we can see that bump a little bit better, I can start to dial in the bump by itself, so I can increase the intensity of that bump map. And again, we're getting that visual representation both in the viewport and the material view. So that's pretty much it for the look dev. And the next thing that we're going to talk about really, that's very, and this, if you had to pick one thing about Maya 2016, that's what is it about? Speed, performance. So not only interacting with the tool, but the actual foundation of the application has been changed for the first time inside of Maya. We now have the ability to parallelly evaluate your scene and efficiently use the resources that your computer has. So in this example, we're working on a pretty amazing computer. We're on a HP Z840. It's got 20 physical cores, 40 threads running at 3.1 gigahertz. It's got a Quadra K6000 card in there. So you want a workstation, this is about as high end as you're going to get. It's actually the first time I worked on a computer this powerful. And Maya now has the ability to tap into that power. So legacy Maya 2015 and earlier, if you had this insane workstation, Maya would scratch the surface of it. It was a bunch of wasted money, essentially, unless you were rendering, right? But the hardware wasn't being fully utilized. And that all changes with 2016 and the parallel rig evaluation. So let's check that out in context. We'll turn off our soloing. We'll close down this hypershade window. And this is a pretty big scene, right? Like if we zoom around and look at this guy, there's a lot going on. The polygon count is extremely high. The texture file sizes, again, very, very high. We've got depth of field in here. We've got hardware-based fog going on, which is new in the viewport in 2016. Bump maps, normal maps, lots of stuff going on. And we've got open subdiv on our character. So we're using a really smooth version of that mesh that's got actual full creases pulled in it. So if we look at this and we play this back, and right now I've got it, the evaluation mode, you can see it's down here. It's set to DG, which essentially means legacy mode inside of Maya. Also notice that my control rig is turned on right now. So if we grab something like his hand and we begin moving this around, this is not a simple rig. This is a full FK, IK squash stretch rig. So if I grab any part of his body and begin moving it around, it's got the ability to do squash and stretch on all the limbs, on the torso. It's a big, gnarly rig. If we looked at this in the outliner and, oh, what did I do? Let's not do that. Let's do perps outliner. If we look at this rig in the outliner and expand it out, let's do this guy right here. There's just so much going on in here for the squash and the stretch and all the twists down the limbs, and it's a big rig, just massive rig, right? So, and awesome that the technical director has set this rig up for the animator. It gives him all the control that he needs to bring this character to life. The problem is, using the legacy evaluation mode inside of Maya, if we play this back, our frame rate's not going to be that great. So 3 frames a second, 2 frames a second, it kind of floats around there. It goes up to 4. It kind of bounces around a little bit. That's not great. As an animator, every frame that I can get is just going to make my day a little bit better. The less that I have to do play blasts, or the faster that if I do have to do play blasts, they go, the better my day is going to be. So we want to get performance everywhere we can. So inside of Maya, and notice that when this plays back, all of those controls disappear. This is a simple little thing inside of Maya 2016, but it actually is really, really cool. In our display layers now, we have the ability to flag on whether or not an object's active during playback. So I've got all that control rigs and all those joints set onto a layer, and when I hit play or scrub, that layer gets hidden. So you can use this to cull information out when you're playing back your animations, again, to get more performance into your scene, or to clean up the view just to make it look a little bit nicer. So what we're going to do is we're going to bring up the performance evaluator, the profiling tool inside of Maya, and use that to really see how Maya's tapping into the resources of this computer. So this profiling tool is really pretty cool. You can set it up to instrument lots of stuff. So we instrument all of these different parts of Maya. If you write plugins or Mel scripts or you use Python to add functionality into Maya, you can instrument your custom tools if you mark them up. Just you got to put the calls in there to let the profiling tool know about them. If you do that, they'll show up in the profiling tool, and you can use that to find out how fast your plugins are, or find out if is my plugin dogging my scene and slowing it down. Well, the profiling tool, if you mark it up, will give you the ability to figure that out. Very cool functionality. So we don't have Bifrost in here. We'll just turn some of this stuff off. We don't really care about that. Viewport 1, don't care about that. And the Qt calls, this is fine. XGen, we don't need in there. So we'll filter all that stuff out. I'm going to set my buffer size kind of low. I don't need to see a lot of data or a lot of frames in here. So we'll do something like 4 megabytes of buffer in there. We'll hit record. So when we hit record here, we'll start our playback. We'll hit record. Maya goes through, and it evaluates the scene, and it profiles it for me. So this is all going to give me a good snapshot as to where my scene is taking its time. And you can see that this data is not packed that tight. It doesn't go very tall. The visual look of the feel of this, after you start to work with it, you'll start to understand, does that look like a good profile or does it look like a bad profile? All the color codings mean certain things, and obviously in the context of a little demo here, we can't really talk about all of that, but if I just frame this guy in, you can see that this isn't a good view of what the profiler, the computer's not using the resources, basically. That's what this view is showing me. So if we jump over to our threaded view, you can even see it even more clearly, how Maya's taping into this computer. So there are some threads, not much happening. One thread, all the work's happening, and then all these other threads, they are not significantly contributing to the evaluation of this scene at all. It's all happening down here on that one thread. That's legacy Maya. That's not cool. That's not what we want to see. So let's go ahead and turn on the new parallel rig. So we'll jump into our system preferences. We'll go ahead and we'll grab animation. We'll switch this over to parallel. So what we're going to do is we're going to evaluate our scene. And it's really intelligent when it does it. If there's part of a rig that can be parallelized and there's another part that can't because it has some weird independency or connection to another, there's a loop or a redundancy in there, it'll rig everything that it can. It doesn't just say, hey, this character can't be parallelized, there's a problem. It'll parallelize 80% of it, and the 20% that it can't solve, it'll just do that in legacy serial. It doesn't care. So now if we run this, we were at, say we were at 3, 4 frames a second. We play this back. We jumped up to 10. So just by parallelizing the rig, we went from 3, 4, up to 10. That's a really, really significant improvement. Doubling, tripling your speed, crazy. Let's go ahead and run this evaluation and see what happens. So here we are in the threads. Let's go ahead and we'll frame in on this guy. We'll hit all on that. So this is the evaluation of the rig, and you can see that every thread now is significantly contributing to the overall, and this is a wrapper showing the whole scene, that thread. But every thread is working hard to make this get to that 10 frames a second from that 4 frames a second. That's exactly what you want to see. If we jump back to our category view, look at the difference in the data shape. Check that out. Look at how packed all that data is. But there's still some really big bars in here. And if we highlight one of these bars, it's going to show me what's taking the time. So that piece of geometry, you can see it's highlighted in the scene there. That's slow. If we grab something like this guy right here, it's going to show you where the speed is slow. And it was actually showing me geometry. Well, that gives me a good idea. If it's geometry that's being slow and deforming geometry, let's go ahead and turn the next component of the parallel rig evaluation on, which is the GPU component. So when we're evaluating the scene and threading it, we're actually going to make a choice about where we want to compute that. Do we want to do it on the CPU or do we want to do it on the GPU? In certain things like deformers, skinning, those guys are going to be really fast on the GPU. Other things aren't going to go, they're not GPU friendly, right? They're never going to want to be on the GPU. We're going to let those guys sit on the CPU. So we're going to split the load across all of the resources on the computer now by turning on this GPU evaluation. So let's go ahead and jump in there and turn that guy on. Now, this is going to be pretty significant. We're now up to over 24 frames per second, floating around 30 frames per second. So we went from 3.4 to 30. That's going to change your day. That's going to make your life better. I promise you, this is a good thing to have. And if we record the data now, you can see that basically all this is the rig. All this over here, this color, that's showing me the draw of viewport 2.0. So the rig is now fast. The draw, the actual screen refresh is taking as long as the rig evaluation. Killer. Really, really cool. So that's parallel evaluations out of Maya 2016. Really does changes everything for you guys. So the next thing that we want to talk about is the Delta Mush deformer. So this is newly added in 2016, and it's a pretty cool tool. It allows you to fix deformation artifacts very, very quickly. So if you're trying to get a character up and running really quickly, you want to have an animator start working with it before even the modeling might be done or something like that. You don't want to spend a lot of time painting nice weights on that character so that the animators can start working with it if you know you're going to throw it away. The Delta Mush tool gives us the ability to get really fast rigging and clean it up. And I'm going to show you an example of that right now. So let's go ahead and jump over to our little custom shelf that I have here. So we're going to get our character back to his bind pose. So we'll bring up the character control tools, and we'll just click this guy to stance to kind of do that really quickly. Let's just do it twice. So I've got my kind of character sitting here at his bind pose, and I'm going to turn off the rigged geometry that we already have inside of here, and we'll get this version that's not been hooked up. So same piece of geometry, same mesh, and I want to do a kind of bad skinning job. I'm gonna give the Delta Mush Deformer the hardest job possible. I'm gonna do pretty nasty skinning on this character. So let's go ahead and just select some joints. So those joints are now selected, and I'm gonna add to my selection my piece of geometry that I want to bind into that guy. We'll jump up to the skinning. We'll go to the bind options, and like I said, I'm gonna give it really bad skinning. We're going to do max influence of 1. So it's essentially a rigid bind. The vertices are going to be exclusively associated to one joint. There's going to be no weighting or interpolating between what vertices is associated to what joint. So it's going to look bad. And this is perfect, right? Because with this Delta Mush Deformer, we can take stuff that's kind of garbage and smooth out those artifacts really quickly and efficiently. So we'll use selected joints, and we'll go ahead and we'll say bind skin on this guy. And if we just hit it back to stance one more time, it'll update that, refresh that guy. And the next thing that we want to do is layer on top of this that Delta Deformer. So what the Delta is going to do is it's going to take it's going to smooth the character out. And then it's going to compare the difference between the smooth version and the reference character and record that difference in the deltas. And it's going to use those deltas or that deformation difference, the difference in those deformations to fix those irregularities or those artifacts. So let's go ahead and create the Delta Mush Deformer. We'll go skeleton, deform, create Delta Mush. So it's on there now. So before we get our character into its animation pose, I'm going to put the envelope down to 0. So I've turned off the effect of that Delta Mush Deformer. Let's go ahead and just get our character back to the animation drive in it. And if we kind of look at this guy, we can start to scrub through here. So you can see, if we look at this guy, there's a lot of nastiness in that. You see all these sharp edges. There's no smoothing in that elbow right there. It's just rigid bound essentially, right? So this is not really beautiful looking skinning at all. So let's go ahead and just start dialing in the effect of that Delta Mush. So first thing we're going to do is turn on it. And even with the default settings, you can see that elbow starts to look a little bit better. And if we start to increase the iterations up to something like 100, you can see that it really starts to smooth out those artifacts, especially underneath this arm here. Like look at that area. So this is without the effect. And just see that, like all that's just horrible looking right there. Like all that area, put the envelope back up to a value of 1, and it just fixes it. And this, if you drop down the displacement, this is going to let you see that's the version, the smoothed version that the deltas are being compared to. That's what's making this nice change, is the difference between the smoothed version and the reference version, which didn't have any change. So those deltas are recorded and used. It's worth mentioning that those deltas are accessible. So if you want to get at those guys and use those in your own, query them and work with them inside of Maya in other ways, with the Delta Mush tool, you can query and get into and use that information in your own deformers or in your own scripts and things like that. So it's a very flexible tool. It's got an API associated with it also, so it's a really cool tool. All right, so the next thing that we want to talk about is, let's just get our character back here to his good-looking version. So we'll turn off the Delta Mush skin and get the other skin on there. And we're going to go back into that stance pose, because the next thing we're going to talk about is some of the sculpting improvements. Actually, it's not improvements. It's a whole new set of tools inside of Maya for sculpting on polygons. And we're pretty excited about this. This is a pretty cool set of tools that we've added into Maya. So we'll go back to our stance pose just to get our guy kind of where we want to work with him. And let's just grab his head here and fix that a little bit there. So the sculpting tools in Maya 2016 are actually based on the Mudbox tech. So they're very high quality brushes directly inside of Maya. With that said, they are not designed or intended to replace dedicated sculpting systems. So if you're trying to sculpt 100 million polygon mesh in Mudbox or ZBrush for detailing work, you're still going to want to do that. What the sculpting tools bring to the table inside of Maya is the ability to work on your base meshes. So if you're trying to do blend shapes, or maybe some pose-based deforming stuff, or you want to do shot-based corrections, or you want to do some basic terrain modeling, the brushes are going to be really good and efficient at doing things like that. And because they're inside of Maya, they can work in conjunction with all the other tools in Maya. You can see it in the context of your cameras. You can see it in context of your animation. So having that functionality directly inside of the application has many benefits, and we'll see a few of those when we start to do a slight blend shape workflow. We want to make some tweaks or some modifications to our base shape of our character's head so that we can start to animate that guy and morph between those. And the brush-based tools are going to give us an efficient way of doing that. So Maya's had the ability to do blend shapes since version 1. It's a pretty straightforward workflow. And what we want to do is just go over here to this version of the guy right here. What we're going to do is we're going to take this piece of geometry, and we're going to first, we're going to add on to it a new blend shape deformer. Now, previously in Maya, when you did blend shapes, you would have to have in your scene all the geometry. So you'd have a bunch of different versions of the head. You'd select all those versions, and then you'd grab the last head, and you'd say, this head receives all these guys as sliders. We've changed the blend shape workflow in 2016 because of the fact that we now have this brush-based paradigm inside of it. We wanted to have them kind of work together efficiently. So what we've got is we've got the ability now to just quickly jump into our blend shape window, and I've got one blend shape on my suit, but I want to get a blend shape on my character's head. So I can just click the Create Blend button, and that gives me a new blend shape on that piece of geometry. Now with that done, I can just simply start to add in targets for the paint work that we want to do. So we're going to create 4 variations or 4 morph targets for this head. So I just added 4 targets in there. These targets are actually stored inside of Maya as deltas also. So we're just recording the difference between the base and the modified paint version. By doing that, it frees up your file sizes a lot, right? Imagine if that head was a 100 meg head and you had 15 blend shapes in there. Well, then you'd have 1,500 megs of data that you'd be saving in your scene. So your files get big, file I/O gets slow. The deltas are tiny to store. So it makes it much more efficient to work with inside of Maya. Another thing that's kind of nice about the deltas is at any time, if you want to get a true piece of geometry out of that, you can just click the rebuild blend shape from this delta, and it'll give you, from that target, it'll give you the actual piece of geometry that you can put in your scene. So now that we've got this all set up and ready to start painting, what we're going to do is we're going to go ahead and click the Edit button. You click the Edit button, there's a pop-up that comes down and says, you're now editing, any modifications you make are going to get piped into that shader, or that slider. So let's go ahead and grab our brush tool. We'll just double click on this guy. And you'll notice that the tool settings for this, anybody who's used Mudbox is going to recognize these tool settings, and that's because they're the same. So we've got our really nice fall off for the tip of the brush. What's the shape of the tip of that brush look like? We've also got all the stamping information inside of here. So if you want to modify that brush as it goes along, with a bitmap or something and kind of stamp that down, we now have that directly inside of the tool settings also. So Maya's always worked really nicely with marker menus. I'm going to just decrease my brush size, holding down my B key, and decrease my magnitude by holding down my M key. So, Maya's, a lot of the speed that comes from Maya is using these marker menus, these radial pop-ups. So all the brush tools are actually shoved into the marker menus also. So just right mouse clicking gives me a radial pop-up for the most common functions that you would be calling inside of Maya. So we're going to just go ahead and do a couple things. I'm going to turn on mirroring across the x-axis. I'm also going to turn on steady stroke. This is something that Mudbox had. Steady stroke takes the wrist. It just averages your movement across, and it removes kind of the noise that you might have in your wrist. So it lets you trace things, lines smoothly, and things like that. So I'm just going to turn steady stroke on. And what I want to do is just add in a little pull on my character and just give him like this really pronounced kind of crazy chin. So really straightforward, and exactly what this tool excels at, working on these base meshes. So great, we've done that. That looks awesome. Let's do another one. So we'll hit the Edit button. So now whatever changes I make are going to get recorded in this next slider. So we're making our second morph target. So what I'm going to do now is I'm going to turn off the mirroring. I'll turn off steady stroke also. And I'm going to just jump into the grab brush. So sculpt and grab and last are the most common things you're going to do. So they're just gestural swipes to the right. So we'll go ahead and we'll say grab brush. We're just going to lift up his lip here a little bit on the side. And one of the things that's kind of cool inside of Maya is if you hold down your shift key with the brush tool, it turns one color. That gives you smoothing. Control gives you relaxing. Control shift gives you relaxing, which is orange. And if you hit control, it's a modifier of the brush. So if you're in a, like a push brush or a pull brush, you hit control, it's going to give you the inverse action. Pretty straightforward. If you're in the grab brush, now we've added, if you hit control, it's going to give you a rotate. So this is new, this kind of twisting functionality on the grab brush. So if I hold control and just grab this guy and sort of start to spin it around here, you can see that I can start to rotate around that point. and we'll just turn our wireframe on so that we can see that effect. So really nice new functionality that was added. This actually made it back into Mudbox also. We've also got a new relax brush. I'm not showing that right now, but the relax brush is inside of Maya is also in Mudbox 2016. So a couple things to keep in mind there. So the next thing that we want to talk about is using some of the things that Maya did before that was really cool. So if I wanted to lift just the top part of his lip, and grab brush would be something pretty good at doing that, I would think. So I'll decrease my brush size a little bit, and I go in here and I start to lift that lip. You'll see that it obviously pulls both sides, right? So Maya has the ability to adjust the type of fall off that the brush uses. So instead of using volume, we're going to switch over to surface, and then we're just going to simply lift that lip up, and you can see that it knows not to grab the bottom lip because it's based on the parameterization of the surface. So these are the things that this tool really excels at because of the goodness that Maya had as a foundation for them to build on top of. So the last thing that we want to talk about really quickly is really where the tools get interesting, right? So right now we've been sculpting on the basic head, right? So if I want to lift the eyebrow on my basic head, I'd expect that other piece of geometry to go along for the ride in my blend shapes or something like that. So this is something that we can do inside of Maya because we can build relationships, and the brush tools can work underneath those relationships. So if there's a dependency, you move the underlying object, the dependent object will assume that same deformation. So let's look at that in context. Let's go ahead and grab our eyebrows. Come on. Maybe. All right, so we'll grab our eyebrows, we'll grab our base head, and I'm just going to go up to the deforming menu and just tell it to be a wrap deformer. So the eyebrows now have a relationship. They're kind of going to get wrapped onto the deformations that we add to our base head. So if we go in here and just grab that brush. Actually, let's do a grab brush on that guy. We'll just grab that and kind of lift it up. You can see that as I start to modify these eyebrows underneath the underlying geometry, the eyebrows go along for the ride. So again, this is sort of the things that Maya can do that a dedicated sculpting tool couldn't do because they wouldn't be these deformations layered on top of the sculpting work. So those are the things that sculpting brings to the table in 2016. So the next thing that we need to talk about is XGen. And there's been a lot of work done for XGen for this release. Actually, every release since we've introduced XGen, we've made significant contributions to its functionality. And for 2016, we've made some really nice ones, mainly speed. XGen's now threaded, so the preview descriptions happen much faster than they did in legacy versions. So let's go ahead and check that out. What we're going to do is we're going to go ahead and just hide the character's hair. And we'll start working with adding in some hair from XGen. Maybe. File's a little messed up now. It's not letting me deselect it. Let's go in here. There we go. All right, so what we've got is we've got a piece of geometry, a scalp, and we want to generate some hair from that scalp. So we're going to be using XGen to do this. Obviously, it's an awesome tool for doing instance geometry work, spline work, and hair work, things like set decoration also excels at. It's a really, really awesome tool for that. In this example, what we're going to be doing is we're going to be using the new XGen presets to assist us in doing this quickly. So if we jump to modeling, there's now a generate button, and there's an XGen library in here. So if we go ahead and we click on the XGen library that ships with the product, these presets may look familiar to you if you've used Maya in the past. What we did is we tried to make the same exact presets that we had in the legacy Maya Fur. If we did it in legacy Maya Fur, we wanted to make sure that we could achieve the same results using XGen, and that's what these presets have done. The thing that's great about the presets is they're going to be an awesome tool for you to learn how to create your own XGen materials or your own XGen descriptions, because these presets, you can start to rip them apart, dig into them, and see what was done to get to that look and feel or that result. Because once you get your head around XGen, it's unbelievably powerful, but it's been a little bit hard for people to get their head around it. So by having these presets, it's going to be an awesome tool for people to get up to speed with it. So what we're going to do is we're just going to grab one of these presets and kind of add it onto this character. So what we'll do is we'll just add in, I don't know, this one. We'll double click on it. We have to give it a few options on how we want to deal with the remapping. I'll just use the default, so we'll hit import. And just like that, it makes a new XGen description, and then it goes through and does the XGen preview, and you can see that the preview happens very, very quickly inside of the viewport for 2016. So that's pretty cool. Obviously, we don't need like fuzzy weird hair on our guy right here. What we're going to do is we're going to go ahead and delete that, and we're going to build up a different description that I actually saved out earlier. So it's the previews and the presets are awesome because they're very easy to move around. So this is going to let you share previews with other people. It's going to let, I imagine there'll be a large library of previews that get made by our users. So it makes working with XGen that much easier because it's easy to move stuff. And that was something that was a little bit hard in previous versions of Maya. So let's go ahead and jump over to the XGen window and just delete this description for the lion hair. We don't want lion hair on our character. And what we're going to do is we're going to jump over here to my preferences. And you can see that I've got a few of them in here. Notice that there are different colors associated with these. When you're working with XGen descriptions, you can generate them in different ways. Are they based on expressions? Are they based on guides? Are they based on groupable splines? Are they archives, for geometry like trees and plants and roofing tiles and shingles? So this gives you the ability to filter your presets as well as a color coding telling you what they are, how they were made. How was that preset generated? So for this example, we're going to do the top spikes. It's just going to be the middle section of his head, of his hair. If we double click on that, it's going to bring up the preset options one more time. And this one was done using guide shapes, so curves basically to guide those instance splines, those primitive splines that generate the hair are going to be positioned and kind of get their overall look and feel from some guides. So we need to tell it how we want to deal with the transfer of those guides from our preset onto our geometry. For this example, we'll just go with, what do we have here, position-based. I like that. That's perfect. So we'll do position-based. So Maya goes through. The first thing you're going to see pop into the screen are the guides. And it's done the mapping onto the head, and then obviously it's going to go through and build that XGen description on top of it. It's going to go ahead and do the preview of those primitive splines that we see in our viewport. So just like that, we now have some hair on our character based on these guides. Now remember I said before, the presets carry all the information, so a lot of the look and the feel of this hair comes from the clumping, all these clumping controls, and then so we have clumps with subclumps, then with even more refined subclumps on it, then a noise on top of that, and then a little cut deformer. So this is what I'm saying, being able to go in there and dig through and see what people did. How did they get that hair to look that way? Did they use clump, noise, fractal? What was going on? So all that stuff comes across in the preset. So that's really pretty awesome. So the next thing that we're going to do is look at some improvements that were made to working with the guides, because the guides really are what ultimately drives the base shape. On top of that, you layer noise and fractal and clumping and things like that to break it up and modify. But those guides are something that you work with all day to get the kind of basic groom happening. So what we've got is I'm going to display just the guides by themselves. It's a small thing, but we've made it so that the guides work with soft fall off. So if we grab these control points, maybe, actually it's not going to work. Let's go ahead and just do it like this. We'll grab the hair with the new grab brush. So we now have a brush-based sculpting workflow. So let's go ahead and grab that guy. And I can use this to really quickly start to modify the overall shape and feel of the hair just using a fast, easy brush-based workflow. So now obviously if we go back in here and we do another preview of this, preview happens again much faster. That preview's threaded. So that used to take a good bit longer inside of Maya 2015. You hit the preview button now, it just goes, boom, bam, done. We've got, thousands and thousands and tens of thousands of instance, thin little tiny hairs. And look at how cool Viewport 2.0 looks. Even if I turn on something like the screen-based ambient occlusion, that's going to work with that hair. So, what we're getting in the viewport before we even commit to a software render is really, it's pretty good, right? You can make creative decisions on this directly in the viewport. So we'll go ahead and we'll turn off that guy right there. Actually, we'll just leave it on. Doesn't matter. Why not? The next thing that we want to do is talk about doing some other things with XGen. So I've got a piece of geometry in my scene here, and what I want to do is I want to use XGen to generate some kind of alien-looking plants. I've got these weird little tubey alien plants in the background there. I want to use XGen to generate some of that stuff. And we're going to be using splines to do this, because we've made some slight modifications and additions to the splines to give them the functionality to do more than just hair or something like that. So let's go ahead and check that out in context. So we'll jump over to the XGen window. Actually, we were already in that XGen window. We'll say create a new description. I'm going to add this into a new collection called, I don't know, I think we're on Tuesday. I don't know. We can just call it T. So I'm going to use splines. I'm going to let the splines be randomly placed across the surface, and I'm going to be using expressions to control those. So we'll hit create. Maya goes through. It does the binding to it, and it goes and makes essentially a little bit of low, thin fur on my ground. I want alien vegetation. So we're going to change this up. We're going to switch the density down to 0.005 to make it really thin. I'm going to increase the length up to something like 50, so they're going to be long, and I'm going to give them a thicker width. And here's the thing that's new in 2016. Let's just make that even better. We'll make it a little thicker there. Is this ramp modifier. So down the length of those splines, I can adjust the overall shape. So think of this as a revolve, essentially, as it goes down that spline. And I can use this to, to really quickly make my own look and feel. Let's just blow that guy away. Get something kind of like, like that. And then we can jump back into our preview and give our preview more to work with. And if I wanted to go in here and maybe change some of these spline handles, instead of being linear, just put them to change the interpolation on those guys a little bit. So in a few seconds, we were able to add in these kind of weird alien plants. And then obviously, if I was building this up, I'd start putting some little expressions on bend and U and V to give these random values so that they were all a little bit different. Maybe I'd put a little randomness onto the length or something like that. But really fast, easy way of getting a slight change. So you can use this to do things like feathers. There's lots of different things that you can do once you can start to change the profile of that spline shape. You can flatten them out and make them into feathers or leaves or whatever very, very quickly. So let's jump into the hypershade window one more time. This time I'm going to use the hypershade window in a docked fashion as opposed to being a floating window. And I don't need to see the preview of that guy anymore. What we want to do is we want to go ahead and just look at some of the shading improvements that have been made to XGen and kind of just talk about them, really, because we've got to keep moving forward here. We've got a lot to get through in the hour. So XGen has had lots of improvements made to its ability to work with mental ray. So we have a new shader. And if we look in our outliner right here and we just grab this guy, you'll see that this material that was put on there by default is the new XGen physical hair shader. So it does a great job of looking much better than our previous legacy hair shader. So that's really cool. Obviously, for alien vegetation, I don't want it to look like hair. So I can now apply to this guy a standard Maya material. So we'll just go ahead and we'll grab this blend. We'll just graph the input of that guy. And we can jump back to the outliner. So you can see how nice it is to have the outliner in my look dev environment as I'm working through here. Like previously, I'd have to pull that up or it would be somewhere else in the UI. So this really shows it in action, the workflow that you have inside of Maya 2016 with this look dev environment. So on top of that, I'm going to go ahead and map on here a ramp. So this would always show up in the viewport inside of Maya when you'd put like a ramp going down something in XGen. But the problem is Mental Ray didn't know how to translate that and render it, right? It just didn't render. So that's been changed in 2016. So we'll just add a second color on these guys, something like this, maybe make it a little green, kind of drop the intensity of that guy down. So we have a little bit of ramp on there. And just for fun, I'm going to go in here to the noise parameters and just put a little bit of noise on those guys to kind of break them up ever so slightly, and maybe a little saturation noise too. So I've done this ramp work, right? And Maya doesn't really, Mental Ray at this point doesn't know how to render that. If we rendered it, it wouldn't pick up that ramp information. So we've got new utilities inside of our environment that allow us to work with XGen really nicely. Oops, let's not filter there. Let's go to our Create tab. And I'm just going to filter out XGen stuff by just clicking XG. So you can see that we have these new additions. And with these, we can really quickly, let's just do that, grab something like the PTEX length mapping. So what that does is XGen length mapping is going to allow me to take the out value and just shove that into this ramp. You'll notice that this ramp is set to be a V ramp. All the information's in V. So instead of having a UV texture placement node drive that V chord, we're just going to grab the out value of this XGen utility and have that drive the V chord. So now what we see in our viewport is what we're going to get in the software renderer just by making that simple connection of kind of providing XGen with the information of that ramp with this new utility node. So that's new in 2016. So with that done, let's go ahead and jump over to Bifrost. We've got 15 minutes to get through it, and it's going to be a marathon. So let's see if we can do it. So Bifrost in 2016 has had a lot of love. Amazing new functionality added into Bifrost in 2016. So the first thing that we're going to be doing is using Bifrost to generate a foam splash. And if we look in our, let's see here, I think I've got some movies here. I do. Let's just jump over to our desktop really quickly, and I'll show you what we're gonna work up to. So what we've got here is I wanted to get something that looked like this. So this is, I worked with one of my good buddies, Igor, amazing artist, and that was the idea. It was like, all right, we want to do liquid. We've got a new foam model. What's great to do with foam? Big splashes, right? So this was a reference. We kind of looked at this and said, can we do that inside of Maya now that we have a foam model that builds up on top of the work that we already did in 2015 with the liquid solver? And I'll show you the workflow really quickly. So what we've got is we've got this already loaded up. So I've already got the Bifrost liquid cache loaded in. So this was pre-generated inside of Maya, and what we're seeing is the flip particle representation of that liquid movement. It's a single frame. The caches are really big. I'm not going to scrub them. I'm not going to try to load them. But we've got a little bit of the splash happening on that rock right there, and you can kind of see the movement of those waves. The color coding sort of shows the speed a little bit. It's kind of the brighter it gets, the faster it's moving, and we have that little mist happening right there. So this is what we could do in 2015. Now in 2016, we can layer on top of that a new Bifrost foam model. So what the foam gives us is the ability to generate or spawn particles based on movement, essentially. So let's go ahead and look in our outliner and make sure that we get this Bifrost liquid selected. So we'll grab that guy right there. And what we're going to do is go up to the Bifrost menu, and we're just going to say create a foam. So if we do that, what Maya's going to do is it's going to go through now. It's actually calculating that. So based on the velocity of the movement of this underlying mesh here, we've just generated a little bit of foam. And you can see that I have that bounding box that showed up and the little white dots. So those little white dots are particles that represent the foam. Now, we haven't generated a lot of foam yet. So what we're going to do is we're going to go in here and we're going to tweak these parameters a little bit. So we'll jump into our Bifrost container. So in the container, you now have this foam section. So foam is enabled, but I haven't emitted enough. So I'm going to crank that rate up to a value of 2. And then we're going to start playing around with the min speed, min liquid, and min curvature. So these are thresholds that need to be exceeded to generate more particles. So speed's pretty straightforward. If we make it a lower value, it's going to be more sensitive to speed. Therefore, it's going to be more prone to emitting foam particles. The next thing we're going to do is drop down, and you can see more particles come in there. We're going to drop down the churn. So in this example, the churn is going to be kind of the turbulence of the water. But keep in mind that if you had something with a lot of twirl or vorticity inside of it, that churn factor is going to be the one that you're going to adjust to really adjust how much foam is going to get shoved into that sim. So we'll kind of crank that guy down, and it's going to take just a second to do that. And then the next one that we're going to look at, and that's that's actually a lot of foam particles there. I'm not going to actually do the next one. The next one would be curvature. So the steeper the wave, the more the water would drop, the more foam you'd expect to get there. So the curvature one adjusts how steep it has to be before foam kicks on. So what we're doing right now is we're emitting foam particles everywhere in our scene. So if I have a shot that's far out, that's great. But if I've got like a locked down camera that's down here that's low, I don't want to emit foam everywhere in the scene because the emission process takes time. It takes time to emit. It takes time to calculate. So we have the ability to call where the particles are being emitted. There's an adaptivity setting that we can set up based on the camera. So we can clip this to the camera frustum. So let's see that in context. So let's go ahead and just show my cameras in my scene here. I've actually got a camera that was tracking. Show cameras. Oh, I didn't bring the camera in. Oh, that's a pity. All right. So essentially what we can do is we can create a camera. So let's just go ahead and do that really quickly. We'll say create a new camera. So from this camera, I'm going to look through it. So we'll just kind of position the camera, I don't know, somewhere like this. I'll set its aspect ratio to 1.85. I'm going to set its field of view or its angle of view to something like 40. Kind of zoom out a little bit, somewhere like that. And I'm going to turn on the display of the camera frustum. So now if we jump back and look at that camera, there's a camera frustum, right? So what we want to do is we want to only emit particles where that camera frustum lives, right? So that's really fast to do. All we have to do is go ahead and grab our Bifrost liquid and our camera. We'll jump up here to Bifrost. We're going to say add this in as an adaptive camera. And then we just need to go back here and turn on the clip to camera frustum. So we'll go ahead and we'll have it just clip into that information. So the camera adaptivity, again, before we've even clipped it, it's basically going to be more prone to emitting particles in the frustum than outside. So we're going to turn it on until it to actually just clip it to that camera frustum. So we do that. Again, it'll recalculate out, and you're going to see that all these particles on the outside are going to disappear. We also have an adaptivity parameter that we can play around with, so we can tweak that to adjust how prone it is to clipping to that, how many particles are going to get based. Again, it's just a threshold gets exceeded. So you can see how we've called down that information, or we've clipped those particles to only live inside of that frustum. And that's, you can really see it here on the beach very clearly. That's a really big deal, because when it comes time to simulate, well, let me show you a couple of examples. And we're using RV to flip our movies here. RV is the newest addition to Autodesk M&E. What an amazing player. Obviously, we're just flipping movies here, but if you've got EXR sequences, if you're trying to do any color work, it's just an awesome compare contrast tools, brilliant, brilliant tool, RV. I'm so happy that we have it now. So what I want to do is just show you a 4-up view of different adaptivity levels. So we'll go ahead and we'll play this back. We've got 10 minutes, so we're going to crank to get through the rest of it here. So what we've got here is we've got 4 different versions with camera activity turned on, and you can see the sim time. So with no camera activity turned on, almost 6 hours. We start to adjust the value here. It's down to value 0.1. We're down to 2 hours and 39 minutes. Then obviously the lower the value goes, the more particles that are emitted, so the sim times go up. But cutting your sim time in half is a really, really good thing. And this is just for the sim. This has nothing to do with the rendering. This is just generating the points that the renderers are going to use. So you can get a sense of the speed improvements that you're going to get by having this adaptivity that Bifrost brings to the table. So let's go ahead and close this guy down, and we'll jump over to this other cut of Maya. Let's make sure this isn't playing back in the background. It's not great. Let's go ahead and jump over to this cut and just bring in a new file. So the next thing that we're going to talk about is the guided workflow in Maya. And guided workflow essentially allows us to art direct the liquid creation. It gives us a really nice set of tools to drive high-resolution sim. So you can use this guided simulation to either be based on a low-res sim that guides a high-res sim, so you sim something that's fast to get the general movement, and then you sim on top of that a more detailed version that's going to have all the fine detail and splashes, or you can use geometry to drive the guide, which is exactly what we're going to do in this example. We're going to be using this polygon mesh to drive this guided simulation. So this piece of geometry is ultimately going to drive the overall look and feel. So this is where it becomes very art directable, because you can just animate stuff and then have that stuff have a liquid sim that picks up all the subtle details on top of it. So let's walk you through that process super fast, because we're running out of time. So we'll go into FX. We're going to say Bifrost. Let's see here. Oh, no. It's not loaded. We'll jump in here and we'll make sure the Bifrost plugin is loaded. There we go. So on top of this guy, we're just going to say, let's create a Bifrost liquid. As soon as we do that, Maya creates, and I'm going to make sure my options are set to background compute, and they are. So Maya creates the flip particles. Those flip particles fill that whole volume. With the guided simulation, we don't need to solve all the bottom flip particles. We're going to isolate that solve to only exist on the top of the surface. This allows you to work with much higher resolutions, have faster sim times, smaller caches, lots of advantages of only computing that liquid on the top. So what we want to do is we want to take that same piece of geometry that we're emitting from and use that as our guide shape. So we're going to say Bifrost, add that in as a guide. So now that we've done that, the next thing that we're going to do is generate a tank or a collision object to hold that information, to hold that. So we'll jump into our channel box, which is right here. We'll turn on that guy. So we're going to grab both of those, and we're going to say Bifrost, add that as a collider. So now that we've done that, we're going to jump back into our attributes for the Bifrost for the Bifrost sim, and we'll turn off spatial adaptivity. We don't need that in this example. And I'm going to jump into the Bifrost guided section and just tell it, yep, I do indeed want you to be using this guided workflow. So we'll go ahead and we'll rewind that guy. It'll take just a second to generate those flip particles, and now you can see that they only exist on the top. So what we're going to do is we're going to make these guys not go quite as deep. This parameter that I'm playing around with, the input parameter for the min-sim depth, actually has a really big impact into the overall look and feel of this. So we'll go ahead and we'll drop that down so that it adheres to it a little bit tighter. Just rewind that guy, and you can see that there those guys are. They're a little bit tighter to that guided piece of geometry. And we can hide this. We don't need to see that guy anymore. So the next thing we're going to do is just modify the parameters so this is a little easier to see inside of Maya. So we'll go back into the attributes for this container. So the liquid node is going to allow me to adjust the display and the viewport, so the particles essentially. We're going to go ahead and just change the color remapping on these guys to something like, I don't know, like the dark color there. So it's going to wipe through that, and we'll make it a little more prone to going into the bright section there. And while we have this highlighted, I'm just going to go ahead and just add on top of that a Bifrost foam, just because I can. So with that done, let's go ahead and rewind this guy, and we'll play back our simulation. So what Maya does is it basically kicks off the sim. It sends data to Bifrost. Bifrost lives outside of Maya. It computes the information, does the liquid sim, and then sends it back into Maya in the form of a scratch cache, which ultimately drives those particles. And you can see how quickly Maya starts to pick up the movement with that guided shape. Look at how those Bifrost flip particles are already just being controlled by that piece of geometry. And you can see those little white caps kicking in. That's that foam model being generated based on the movement of that underlying liquid model. So we have this really nice high-res sim happening on top of that piece of geometry. So here's an example, again, shown in RV, of what different min depth values have on the overall effect of this guided sim. So the idea here is art directability and speed, right? So if we play this back, we'll just zoom this guy up full screen and play it back one more time. Lower right is with a min depth of 1. So it's a thin surface, and it really is adhering to that guided piece of geometry, but we do have subtle details of that high-res sim on top of it, a little splashing, little sweetness there. We go a little bit deeper with a depth of 2 right here on the lower left, and obviously the deeper you go, the more energy gets transferred into that sim, so the waves get a little bit bigger. But it still has the overall effect of that guided shape. As we start to move up here to a value of 2, well, the guide is still there. You still see clearly that we've got that guide shape driving the overall movement, but we have a lot of subframes and crazy splashing happening on that. And then obviously when we go over here to a value of 3, it's just going nuts, right? So it gives you an artistic ability to adjust how much the guide is going to be visible and how much kind of secondary sims happening on top of it, all on that min depth threshold. So we've got 4 minutes to talk about Aero. I don't know that I can do it, but I can certainly try. Let's go ahead and jump back into this scene here. So we're going to turn off the display of this guy. And what we want to do is use the new Aero solver inside of 2016. And what Aero does, oops, wrong file here. Let's jump over to this one here. What Aero does is it gives us the ability to do really nice atmospheric effects in Maya. So it's a great solver for doing all kinds of cool stuff. We can just blow that away and blow that away. And we're going to use it to generate some blasts on our character here. So if we go to frame 800 and we kind of move forward in time, you can see that we've got this robot coming in here and kind of blasting our guy. So we want to use Aero to generate some really cool smoke trails. And we're going to do that, again, using Bifrost. So we're just going to say Bifrost, create Aero. The Aero model works very similar to the guided model, where you can have low-res sim data driving high-res render data. So the render particles and the underlying flip particles are separated from each other. So I'm going to just kind of crank through this guy really fast to set this up. So what we did is we had these pieces of geometry, these highlighted when we made the Aero, so they're already matted in as emitters. We're going to change our master voxel size down to a lower value. So this is going to set the resolution of the flip particles, the actual sim. We're going to put that down to a value of 0.05. The factor is for the render particles. So this is going to specify the resolution of that voxelized space for the render particles. It's a multiplier of the master voxel size. So if we put this down to a value of 0.5, that's going to make it twice as small, essentially. So our render particles are going to have twice the resolution of our sim particles. So we're going to have high resolution render particles being driven by a low resolution sim. We're going to jump back to the particle density. And again, because the render particles are independent from the flip particles that are used to drive the movement, we can have them be a little bit more dense. We're going to do some adaptive time stepping. So this is something that's very, very cool. It allows the Aero solver to efficiently work in a massive computational domain. The scene that we're going to be solving in is really, really big. And Bifrost can deal with that really nicely with the Aero solver, where the legacy Maya fluid solver would have a hard time with this. It would also have a hard time with fast-moving objects. So this adaptive time stepping allows us to efficiently work with fast-moving objects. So with that done, what I'm going to do is I'm just going to cache this guy out. We'll rewind it. We'll hit, let's set our start frame to 880. That's important. And I've got 1 minute, so hopefully we'll get some particles in our scene in 1 minute. So Maya goes through. It starts to, you can see that it's going to kick in here at frame 880. You look at the time slider. So as soon as we get to 880, I should have probably set that a little earlier. There goes the Bifrost object getting cached out. So bam, 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 just like that. We get these really nice Bifrost-generated Aero solver, trippy little smoke trails kind of coming off that guy. So that's an example of Bifrost Aero solver in action. I'll show you the end result of this guy. And again, it's really great at doing atmospheric effects. So we'll finish off by looking at 2 movies. This is just that beach movie one more time rendered out. And what we've got here is obviously the liquid, the Bifrost Aero giving this overall volume, the smoke trails. Notice when it hits the rocks there, we get this little blast. That blast is actually really cool. If you look at that before the comp, before it was toned down in the comp, just seeing the Aero of that is just, it's really beautiful. So that's the Aero of that. And this is something that the legacy solver, the legacy fluid solver would have a really hard time with. So thanks for taking the time to check out Maya 2016. We saw the new look dev. We saw the kind of updated UI, all the amazing performance information or performance improvements we've made, the Delta Mush deformer, sculpting, XGen, Bifrost doing guided simulations, foam models, adaptive Aero. If you're interested in Maya and you want to learn more, please go over to the leads desk and have your badge scanned. We'd love to talk to you about it in more detail. Thanks, everybody. Have a great show. I appreciate your time.